Welcome to Academica's Aqua Circular Conference. My name is Glina Kirillă. I will be your host for this webinar. Mr. Philip Velge will make the presentation instead of Mr. Thomas Dietrich, who had also some technical issues. Mr. Velge, you may start your presentation. Please open up your microphone. It's a little icon. Okay.
Okay, yeah, thank you. So thank you. It's a bit last minute that I have to fill in for Thomas. Apparently he had some connection problems. I'll do my best to fill his footsteps and tell you a little bit more about the Volatile project. I'm sure it will not last the full 20 minutes as Thomas would have foreseen it, because I will have to improvise a little bit, but okay, I will do my best. If there are questions at the end, you also have Thomas's contact details. So if I'm not able to answer them, you can for sure connect with him. Okay, let's start. I will try to explain a little bit more about the European Volatile project, which is about bio-waste-derived volatile fatty acid platform for biopolymers, bioactive compounds, and chemical building blocks. Okay, Thomas prepared a few slides on what Tecnalia is. It's a very big company in Spain doing a lot of research in a lot of different fields. Here you can see them. Most of them are in bioeconomy, food, biochemistry. I'm sure Thomas will explain you a lot better. Maybe he will prepare a video to be put online afterwards. Let's see. But okay, that's for now. So then, what made us start with the Volatile project? It was actually a challenge to go from a linear economy where we take resources from the environment, make a product, use it, and then dispose of it. But as we all know, finite resources do not allow us to do this for eternity. So we have to go to more a biocircular economy, where we reuse resources as much as possible, recycle them, upcycle them, or try to at least recover some of the material. So in Europe, there are 8 to 9 million tons of dry matter sewage sludge, and as you all know, it's a big issue to treat these sludges. But on the other hand, it's also a big opportunity to see them or to recover them as a renewable resource. So to that end, we started the Volatile Consortium. It's 21 partners from 9 countries, 7 SMEs, 8 industrial and 8 research facilities. So also 2 Romanian partners, Aquasurf and Tritech, who are also partnering this conference. Also one of our partners, or 2 of our partners active in wastewater treatment are Aquafin in Belgium, who I think Francis presented yesterday, and of course Aquasurf, who most of you probably will know as one of the major water treatment plants in Romania. So what are the objectives of the Volatile project? It's to use wastewater treatment plant sludges, municipal bio-waste, industrial organic residues, any organic waste from society, as we can say, and to use this in a modified anaerobic digestion process, where we do not only produce methane but also recover the volatile fatty acids, which in turn can be used for a wide array of other applications, secondary fermentations, for example, PHA production, single cell oil production, or omega-3 fatty acid production. But there are many other applications that are possible that were outside of the scope. But of course, it's not that we're blind to them. And in such, create a final application, a renewable product, and also look at possibilities to reuse, recycle, or if not possible, biodegrade these products, so that we don't create a new problem, but actually make the full circle. It's not only a technical approach, so there was a lot of, we were also looking at the market opportunities, the current market, the legislative aspects of it. SAN workshop agreement was prepared to more or less standardize the work that we've done. And there's also an agent-based modeling approach to fit in together all the technical and non-technical parameters, which is finally resulting in a web-based decision support tool for any company to investigate if the volatile fatty acid platform would make a good contribution to their current working. So in my next presentation, which starts in half an hour, I will tell you a little bit more about the volatile fatty acid platform itself, the technical details. So don't worry, there will be a little more explanation there. But roughly, we are making fatty acids. We use a membrane to separate them, and then we get actually a concentrated and pure VFA liquid, which can be used for other applications. So these are some of the applications that we investigated in the project. It's PHA, single cell oils, and omega-3 fatty acids. So our partner Biotrend from Portugal was doing all the research into the PHA production. As I'm totally not an expert on this, I probably will be more brief than Thomas would have been. But if you have questions on this, don't hesitate to ask them. I can forward the questions to Thomas or to the partners from Biotrend if necessary. But in theory, you can see here on this in the left bottom that the different volatile fatty acids can be converted by bacteria to produce different polymers. So most of them can be produced to hydroxybutyrate, but there's also hydroxyvalerate and also some hydroxyhexanoate. And also in the project, we were able, or Biotrend at least, was able to produce a third polymer with these three polymers, which is very promising because the composition of this third polymer was so that it showed much more promising flexibility. It's not brittle anymore as pure PHB would be, but it shows very good characteristics to be used in packaging material. So then the volatile fatty acids in single cell oil, which is mainly investigated by the University of Minho, also from Portugal, and from Boku in Austria, University for Bodemkultur. So they used yeasts who could grow on the volatile fatty acids. It was mainly acetic acid, if I'm not mistaken. That was the optimal carbon source for them to grow on. And as they were growing, they were storing oil fats in their cell biomass, which was then later extracted and could be used to produce in the oligochemical industry. So as you see on the right bottom, we were able to produce already a small soap from our lab-produced volatile fatty acids. So the technology is proven. It can be done. And then final application that was investigated in the project by mainly Technalia, University of Athens, and BioZoon from Germany, was to convert the volatile fatty acids using heterotrophic algae to omega-3 fatty acids, which could also then be extracted and applied in food or feed additives for health benefits. So as you can see here, there are a lot of fish oil-based COVID-19 treatments. So although we did not know about the COVID, luckily maybe at the time we started the project, but omega-3 fatty acids are recognized globally for their health benefits, and maybe also they could contribute to getting the virus under control. So who knows, maybe our project could also contribute a small addition to making an end to this unfortunate pandemic that is spreading on all of us, and which is also the reason why I can't explain all this to you in real life, unfortunately, but through a video presentation. So another overview of what I've just said. So we have the volatile fatty acid which permeates in the center, and as you can see in the project, we were able to produce. These are all stuff that we produced in the project. The soap, the omega-3 rich oils, and then we also already produced a few films from the PHB, PHA mixtures that we made. So it's still on a small scale. It was, of course, also a research project, but I think we can be very proud of ourselves that in this 4-year period, we were able to start from scratch and produce actually three more or less final products that could, in fact, be used. So these are more or less the technical things. So as I explained at the beginning, we also did some non-technical stuff. So of course, the big one is the market. So we prepared a report on the market demand for these biomolecules coming from biowaste valorization already in 2017. So it's an important fact to know what the market demand is. It's no use of producing some high value products if there's no market to them. So that was an important step to assess our market potential, which in later turn is then be used for economic evaluation. An equally important aspect is the legislation, because it's a new technology, so there is not custom-made legislative aspects that are covered, but okay, you have to work within a legislative framework. So our German partner Wiedemann did a very thorough investigation of both European legislative barriers and also stimuli, like some taxes on fossil fuel-based products or subsidies. But also for each of the partner countries, a report was prepared to see what is the possibilities to go to the market from a legislative view with this new technology. Then KPAT from UK and assisted by University of Athens did the economic aspects. So it's was also deliverable with the initial costs situation analysis on municipal solid and sludge biowaste treatment. And as well an environmental performance check to see how sustainable in the end this new technology is compared to the state of the art. Unfortunately, I cannot give you final results on these last aspects as the work is still ongoing. As due to COVID, we also had some slight delays in getting everything right. But from what I understood, it looks quite okay, especially the environmental performance is expected to do much better than the state of the art. Economics, of course, will largely depend on subsidies, which might not at the moment be installed. But with the Green Deal coming into play now, we expect that there will be a lot of opportunities to bring technologies like this to the market on the short to medium short term. So then we have the agent-based modeling. As I said, we're our Flemish partner Ilvo try to integrate all these aspects on also the technical, non-technical aspects to integrate how they work together, how they influence all the stakeholders that are involved through this. It's the organic waste generation, treatment, and processing all work together. And on all three levels, there's policy, there's regulation, there's subsidies, but there's also how people socially are expected to react on this. And this agent-based model was then translated by our Spanish partner Ode to an easy-to-use decision support model, which is online, where you can calculate already based on the waste characteristics that you have, what you could expect from this volatile fatty acid platform, what would be the costs and incomes associated with it. So then we had a Sun workshop agreement, which was led by our partner Dechima from Germany, where we tried to put the work that we've done in the project to put it available as a sort of methodology on how an anaerobic digestion plant could assess the feasibility of this new technology for their specific plants. Would it be an interesting path for them to go on, or should they look for another opportunity? You can all read the SEN workshop agreement on the link that's on the slide. And then we also have a stakeholder platform where you can join for free, and you can find a lot of articles, public deliverables, interesting links to our project. You can also contact us there if you have an interest in working together somehow with the project or one of the partners. So it's a platform to on one side spread some of our work to the general public, but also to interact with partners that are not involved in the project. So I think this is more or less the final slide. This is all of us. It was a very well organized, warm and enthusiastic group of people, which was necessary, I think. Otherwise, we would never have reached these good results. Also, I want to use the opportunity to make some marketing for our final conference, the Volatile conference, which will go on the 3rd November 2020 online, unfortunately, due to the COVID. But you can find more information on our project website. So here also you find the contact details by Thomas. Also my details are here, and Bianca's from Dietrich, and some interesting links if you want to know more information about it. So a lot faster, I think, than Thomas would have done. Maybe a little bit less information than Thomas could have provided. But nevertheless, if there are questions, I'll try to answer them. If I can't answer them, I will put you forward to Thomas. So
thank you very much. Thank you for the presentation.
Thank you.
And if there are any questions, we are waiting for them. We have a question. What about the flexibility of the platform technology in relation with sludge characteristics?
Okay, maybe I'll try to answer this briefly, because I will tell a little bit more in my own presentation, which is coming up next. So I can't tell you too much about it, otherwise you won't listen to me anymore. But it's a very important aspect, and it's a research that we're still performing on, because the characteristics of the wastes, I mean the sludge, but also the bio-waste, determine a lot, not only the yield that you can expect from a material, but also the composition that you can, I mean the share of acetic acid, propionic acid, butyric acid. It's very depending on the characteristics of the sludge, what it's composed of. So yeah, one way to do this, if it's a characteristic, you cannot change much about it. You can steer it a little bit by process parameters, which is one of the things that we are try to research in the future, as it will be an important step to bring this technology to the market, because you cannot have a volatile fatty acid production that's too variable and that's changing throughout the year when the input composition changes. So we will have to be able to produce a more or less stable output. So you can steer it a little bit by the process parameters like pH and temperature, residence time, but also looking at co-fermentation or co-digestion, by mixing different input streams, you get the results or the spectrum that you want.
Thank you for your answer. And if there are no more questions, then we can stop here, and we are waiting for you in 10 minutes.
Okay.
Okay. Thank you.
Thank you.
Bye.
Bye.